Today we're going to work on just a few more rational word problems. These today are going to be just a little bit more complicated than the ones I got y'all to do yesterday. So, starting off with the first one, working together, it takes Sam, Jenna, and Francisco 2 hours to paint one room. When Sam works alone, he can paint the one room in 6 hours. When Jenna works alone, she can paint the one room in 4 hours. Determine how long it would take or Francisco to paint one room if he was working on his own or by himself. So, what do I know? I know that it takes Sam one room in 4, Jenna, don't make my mistake, Sam was 1 out of 6, Jenna was 1 out of 4, Francisco is 1 out of X, where our fraction here, A over B, where A is the room, B is the number of hours, okay? So it says if we want these three people to work together, S plus J plus F, and it tells us one room in 2 hours, where we know Sam is 1 out of 6, Jenna is 1 out of 4, Francisco, again, 1 out of X equals 1 out of 2. While I'm getting this typed in, right, we know how to solve it. We're going to take everything on the left, put in Y equals, take everything on the right, put in Y equals. As I'm doing that, I'm going to talk about where this is useful in the real world. Say you're working with a group of people, or your boss sends you out with a couple of people to do something, and you try and convince him that, hey man, it would be a lot quicker, it would cost you less money at the end of the day if we could get one more person working with us. And so they say, okay, well, I'll give you, I'll take your word for it. They send it, so he sends another person. Well, by doing this right here, he can figure out how much time that y'all should be gone. And as long as you beat that time, he's going to say, wow, they were right. So the next job you go out and do, he'll like, you won't have to ask. Your boss will allow you to take somebody else out because you're saving money. You're saving the company money, and you're also getting done quicker. Now, in that exact opposite context, I guess, you go up to your boss, you say, hey man, it would really be nice if we could get an extra person, we could get it done quicker. And they say, all right, but you don't, or you don't beat the time that math says, okay, these three people went out, did this job, and they should have been done in this time, but it really took them, an hour or two longer than what was needed. So, just wanted to quickly explain where you could use this. I got 12. Remember, your solutions, again, is the X value where your graphs intersect. I want y'all to do the Melissa problem. I'll talk about this juice problem. So, I have 10 liters of juice, or 10 liters of a juice blend that's 60% juice. How many liters of pure juice would needed to be added in order to make a blend that is 75% juice? So what I think of when I see this, if I have 10 liters of a juice blend, okay, really important here. Juice blend tells me it's a mix, key word there, mix of pure and I'm just going to say water. And this, so knowing 10 liters is 60% juice, that tells me to get this percentage of the 10 liters, that tells me that 6 out of the 10 are pure and 4 out of the 10 is water. Okay. In question A, it wants 75% juice. Okay. So that tells me 1 out of 4, or a quarter of the mixture, is water. And I need 3/4 juice, or pure. Well, currently I have 6 out of 10. So, and I need 3 out of 4. So how do I get there? A couple of ways you can do it is figure out what number of what numbered or how many liters of juice will get you to 20 or 25%. A way that you can do that is 4 out of 0.25 equals what, and that what is 16. Another way you could do it is say, okay, so knowing that I have 16 liters, and then 16 times 0.75 would be 12. So this is going to be pure. This is going to be water. And then my total mix is 16 liters. So I would just need to add 4 more liters. Excuse me. I'll need a 16 liter mixture. So I would need to add 6 more liters of pure juice. So I want y'all to try and do B, and also come down here and do D, and the last one talking about Bob painting the fence.